In this video lesson, we will be learning about transformations of rational functions. Here is the rational function y equals a times a over x minus h plus k. Now, we have seen transformations before with other functions, and much of it is similar. Here, with the x minus h, this is our horizontal translation or shift, right or left. Remember, if it's a plus h, it goes left, and if it's a minus h, it would go to the right. It's the opposite of what we would think. The plus k is the vertical translation, shifting up or down. If it's a plus, it shifts up like we would assume, and if it's a minus, it shifts down. Now, in this function here, you see two different a's. Here at the front, first of all, if this is a negative value, then it is a reflection over the x-axis. Then if the absolute value of this number is greater than 1, so then it's greater than 1, then it is a vertical stretch, such as a 1.5 or a 2 or a 5 or whatever. That's a vertical stretch. Now, it could be a negative 2 as well. It's a reflection and then a stretch of 2. And if that number is a fraction, or if it's a number that's greater than 0 but less than 1, and that should say less than 1 here, then it is a vertical compression. Same with this a here, or the numerator in the fraction. If that number is greater than 1, then it is a vertical stretch. And think of that as this constant over the coefficient with x, which is 1 if we don't see a number. So like that would be like a fraction, but if it's a 2 and then just an x, it's like 2 over 1. Anyways, that's a vertical stretch. Or if you see a 1 over a, and then there's a 2 in front of this x, like 1/2, that's where you would see your compression. Okay, and we'll look at some examples that'll make sense of that. All right, then let me just scroll here through these notes. Here, looking at this first example, f of x equals 1 over x plus 3. Well, the only translation we have, or transformation we have going on, is this plus 3 with the x, which is a shift left 3 units. Looking at this example, f of x equals negative 2 over x minus 3 minus 2. Okay, so this negative is a reflection over the x-axis. All right, and this 2 is the vertical stretch by 2. Again, this is a rational function, or think of it as a fraction. It is 2 over the 1x, 2 over 1, so that's a stretch of 2. Now the x minus 3, that's where it shifts right 3 units, and the minus 2 shifts down 2 units. In this example, f of x equals 1 over 2x, or 1/2 x. 1 over 2x. So that is where we see our fraction of 1 over 2, which is a half. So that's actually a vertical compression by 1/2. All right, in this example, f of x equals 4 over x minus 1. Well, the 4 over 1, that is a vertical stretch by a factor of 4. And then the minus 1 would just be down 1. Okay? And then if you read this statement, a rational parent function is reflected across the x-axis. It's vertically stretched by 3 and then shifted 6 units right. You should be able to write that function. The reflection is the negative. The vertical stretch is a numerator of 3 over, and then it shifts right 6 units, so that would be x minus 6. And finally, this last one, a rational parent function is vertically compressed by 1/3, then shifted down 4 units. The way we write that vertical compression is 1 over 3x. That's our 1/3. And then, of course, it shifts down 4 units, so we have a minus 4 out here for the plus k value. All right, now let's just look at some graphs. So here I've graphed a function for you. It's f of x equals, or y equals 2 over x minus 3 plus 5. Let's quickly just talk about the transformations. So we have a stretch of 2. We have a shift right 3 units and a shift down of 5 units. So you can see that here. And I need to go ahead and add that stretch. All right, let's take a look at this example. F of x equals negative 3 over x plus 2 minus 5. First thing you might see is this negative. That is a reflection over the x-axis. And then we see x plus 2. That would be a shift to the left 2 units, and a minus 5 would be a shift down 5 units. And then last thing, we have this 3 in the numerator, or 3 over 1, which is a 3. That is a vertical stretch of 3. When we graph it, we first begin with the left 2 and down 5. So from our original origin, I go left 2, down 5. Kind of becomes my new origin, or kind of where the graph would start from. Then normally we go up 1 over 1 or down 1 to the left 1. But in this one, first of all, it is this reflection. So instead of being down here, you see the graph, it's graphed up here. So, but we are going a stretch of 3. So that will be up 1, 2, 3 and over 1. You see it intersects there, or down 1, 2, 3, and it intersects there. Okay. All right, let's take a look at another one. Okay, in this last graphed examples, I have 2 compressions. So f of x equals 1/5 x. That is a compression of 1/5. I want to show you what that looks like. So there's no shift right or left or up or down. So here we are at 0, 0. Normally we would go up 1 over 1. Now this graph has been zoomed in quite a bit. So up 1 over 1 would normally be here, but we're going 1/5. So notice you can see that it kind of does go up 1, but then this point right here is only 1/5 of 1 full unit. So that would be our 1/5. This one here, f of x equals 2 over 5x. We could think of that as a compression of 2/5. And in that one, we would go up 2 and over 1/5. And you can see that it intersects there at 1/5 of the 1. So that is our 2/5 when we graph it. All right, and that is a look at transformations of rational functions.